Hello everyone. In this video, let's discuss about the first order RC circuit response to a square wave input. Let's assume you don't have the signal till here, and this is 0 time, this is t by 2, this is t, and this is 2t by 2. Okay, and before analyzing here, you need to ask a few questions. One is, what is the relation between time constant here, tau, which is RC, and this t by 2 of the signal, input signal. Okay, so here what I'm mentioning is, so time constant tau is far less than r t by 2. Here this means I will again write tau time constant is far less than t by 2. That means within this pulse, one pulse, the capacitor will completely charge to V in and stay there. Okay, that is what it is being mentioned. Okay, so in this scenario, let's see, still here this is 0 volt. You assume here also you assume here 0 volt, so that's why I'm writing here 0. Let's assume at t is equal to 0 time, you can see the high frequency signal are being applied to capacitor. So if I redraw the circuit there, this will become like this. The resistor and a capacitor is being short circuited, and there is a resistor and capacitor short circuited here. So if I write the current, so flowing through the circuit, this will be V by R. So assume this is V, and here also this is V, this is minus V, this is plus V, this is minus V. Okay, let's assume like that. So current is flowing is V by R, so that the current is positive. So I'm taking, if the current is flowing in this way, this is positive. If the current is flowing in reverse, this is negative. So this current is V by R, and capacitor will start charging, and it will reach to V volt and stay there. That's what here we already mentioned. Tau is far less than the T by 2. Tau is here RC. Okay, so this will reach to V volt. In the same way, the current flowing through the circuit will exponentially discharge and de- decrease and will reach to 0 ampere. Okay, in the same way, the voltage across the resistor will follow the current profile. It will follow and it will become 0 volt. So here the voltage across the resistor will be VR into R. Okay, which is I into R only. Okay, it will reach to 0. At the same time, at a t is equal to t by 2, we can see there is a, again, high frequency signals are being applied to the capacitor. And let's draw equivalent circuit at t is equal to t by 2. At t equal to t by 2, if I redraw the circuit, this is like this. Okay, so you can say that there is a resistor and there is a capacitor which is short circuited, but here now it has a initial charge which is charged to V volt. So here you can say VC equal to V volt, and here the voltage is negative minus V, and there is a R. Okay, and let's assume still current is conventional current is like this, and if I apply the KVL here, it will be minus V minus I into R, that which is voltage across the resistor, then minus VC, which will be V equal to 0. So if I want to consider I equal to 2V divided by R. That means current here we are getting a negative current. That means current is not going in this direction, current is reverse direction. Okay, so now current suddenly from 0 it went to 2V by R. This is minus negative minus 2V by R. Here previously it was V by R. Now it went to minus 2V by R. The same way the VR will be minus 2VR divided by R. R will get cancelled. It will be minus 2V. In the same way, now what will happen is the capacitor will go from positive V to negative V, and it will settle at it will come like this. It will settle at minus V. Okay, this is minus V. It will stay like that. So in the same way from here, right, the current flowing through the circuit will eventually become 0 with the time constant RC only. In the same way, voltage across the resistor will follow the current profile only. So from here again, let's analyze at t is equal to t. Again, there is a high frequency signal being applied to the circuit. Okay, if I see the redraw the equivalent circuit again. Let's arrange few things here so that it will be easy. So if I redraw the circuit there again at a t is equal to t, the positive voltage is being applied here again, and there is a resistor and there is a capacitor which is getting short circuited because of high frequency signal. And here if you see, this is minus V volt, okay, and this is here, okay, this is R, and this is V in, and still I assume a current is flowing like this. And one more thing here, I understand that here it might take more than uh, uh, whatever the time it took from here to reach V volt, right? Here the time, if you come calculate from, it is taking from V volt to minus V volt, it will be more. But still we have time constant tau is far less than t by 2, so that within next time from t by 2 to t cycle, it will reach minus V volt. So I forgot to tell there. So okay, so again let's write a KVL here again. So we see V volt, okay, minus I into R, and minus V volt equal to 0. So here if you say I equal to, so sorry, here V is positive, so I is equal to 2V divided by R, so that I is 2V divided by R. Okay, so here I will go to this is 2V divided by R, which is greater than uh, sorry, this is the voltage into here, this is R. So this will, here the current will go to 2V divided by R. Here previously during starting this is V by R, here this is 2V by R, and here the voltage will be 2V by R into R will get cancelled, this is, will become 2V. Okay, this is the voltage across the resistor, and the capacitor will again, it will go and charge to V volt. Okay, and here the current will exponentially come decrease and become 0 ampere. In the same way, voltage across the resistor will follow the current flowing through the circuit, it will come to 0 volt again. Okay, this cycle will follow to the through until we have the input voltage. And I have simulated the same circuit again. Let's see what is the result. So this is the circuit I have simulated with 100 ohms and 1 microfarads. If you see, this is the input voltage which I am applying from 1 volt to minus 1 volt, so that the VC is suddenly becoming to 1 volt, and again it will be coming to minus 1 volt. You can see the current flowing through the circuit. Here it started with some V by R, again it went to 2V. Here it was like 10 milliampere. Here it became minus 20 milliampere. It again 20 milliampere. So whatever we previously saw, and here this voltage across resistor will be I into R. Okay, you can see the same cycle is being repeated from starting itself, because time constant RC here is far less than T by 2. This is T by 2.